All right, friends, here is a little crash course review of sequences and series for us to be able to remember everything that we need to know about them. So start off with some basic definitions up here, right? Sequence is just a set of numbers written down in a specific order. The important thing about it is that the domain is going to be a set of positive integers, meaning that we start with 1, 2, 3, and no decimals, no zero. Other things that are important is the summation notation. So remember, we start off with this at the bottom. So this is saying what term you want to start with. So the first term, and then what term to end with. So in this case, the nth term. And then this is saying what the rule is that we should actually follow to figure out what those terms actually are. So that's just notation, so you're familiar with it. And let's practice this, assuming this thing lets me write. It sometimes doesn't like me. I think we're okay. So we put the giant E thingy. We're going to start at k equals 1. And since we don't know where we're ending because of this dot 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 here, we're just going to put n. You could also choose to put infinity if you wanted to, because it is kind of saying like it's going on forever. And then this looks like it is a geometric sequence where we're just multiplying by 3 each time. So I'll just use the rule for geometric, which I think is on the next page in case you don't remember what it is, but it's the first term times what we multiply by, and then we match letters, so k minus 1. And so there's summation notation. This is just asking us to write out what this actually means. So we're going to start at k equals 1. So I'm going to do 1 to the 4th. So I'm just plugging it in to the rule and then adding that. And I'm going to add all the way up until k equals 6. So 2 to the 4th, 3 to the 4th, 4 to the 4th, 5 to the 4th, and 6 to the 4th. And then I'll leave you to be able to add those up because I didn't make an answer key. So yeah, I guess drop a comment if I mess something up. So arithmetic sequences. So this is one of the two big ones. So arithmetic sequences is when we have a common difference, which basically is when we're adding or subtracting by the same amount each time. And we have A1 is the first term. So this is our best friend. This is the formula that you need to have memorized for arithmetic sequences. Then we also have the sum of an arithmetic series. So that's when we add a bunch of things together. That is also going to be the one. You can memorize either one of those formulas. I highlighted the one that I prefer. So let's just do some examples using these just so that you see them. So write a rule for the nth term of the arithmetic sequence if blah, 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 and blah, blah, blah. So there's two ways to solve this one. One is to use a system, but either way, we're talking about individual terms right now and the rule, which is going to be this big equation up here. So I'm going to plug things into that. So I'm going to have 148 equals A1, which I don't know. This is saying that n equals 10 when an equals 148. So I'm going to do 10 as my n value, and I don't know the common difference. I'm going to do the same exact thing with the other point, so the other term I mean. So 556 equals A1 plus, this time 44, minus 1 times d. And then I just like to clean this up first. So it's basically just a rewriting step where I just write it as 9d and then the other one as whatever that number is that I can totally do in my head. There we go, 43. Now we have a system of equations, so we're just going to subtract these things. I'm going to write my answer up there because I didn't give us a lot of room here. And since I don't have an answer key, you get to hear me typing it into my calculator. I am not going to show you the calculator because that would be annoying. My computer doesn't like it. The A1s are going to cancel each other out, and I'm going to do 9 minus the 43. I'm going to get negative 34d, and then I'm going to do 408 divided by the negative 34 to get that the common difference is 12. Now, friendly reminder that you can also do this when using slopes, where we basically would do 556 minus 148 all over 44 minus 10, and you're also going to get this same value. Once we have this, we're going to plug it into one of the two equations there. So I'm going to plug it into the first reduced blue one, where we now know that d is 12, and we can pretty easily solve for what a1 is going to be. So 9 times 12 is 108. I'm going to subtract that to the other side, and I'll get that a1 has to equal 40. And so now to write the actual rule, I just fill in the blanks of that big equation way up there. So leaving n as n and an as an. If you want to simplify that, you can, but you can also just leave it. All right, if this was a multiple choice question on a final exam, you would just use the sum formula in your calculator. If you have to show work for this, then we're going to recognize this is an arithmetic sequence. A1 is going to be when k equals 1, so 2 times 1 minus 5 is going to be negative 3, and then the slope is going to be our d value, so we know that d is going to equal 2. And then I also want to figure out what the last term is, which is going to be 80. That's from this. This is saying that n is equal to 80. So I'm doing 2 times 80 and then minus 5. That's going to give me 155. So now that I have that stuff, I can use this rule right here, n over 2 divided by the first term plus the last term of the sum. So that's going to be 80 is my n value over 2 times my first term, negative 3, plus the last term in this particular one, which is a80. And then I just do a bunch of math with that. And I got 6080 is the sum of the first 80 things, which is what this entire thing is asking us for. Hopefully that wasn't too crazy difficult for you. Next one, when we're thinking about that formula, we need to know what A1 is, which we got. It's 2. We need to know what the last term is, which is 70, but we also need to know the number of terms, and we don't know that. So I'm going to use that last term there and say, hey, when an equals 70, okay, and I know A1 is 2, and I don't know what n is, but I can see my common difference is 2, then I can reverse engineer what the n value needs to be in order for an to equal 70, right? So I'm going to subtract the 2 over and give me 68. I'm going to divide by 2, which is going to give me 34, and I'm going to add 1, which gives me 35, and now I can just plug it in because I know that there are 35 terms, so 35 divided by 2, first term, which is 2, plus the last term, which is 70, and I'll leave that for you to be able to plug it into your calculator. A word problem now. So how many rows are in the corner section of a stadium containing 240 seats? So this is the sum. So we're most likely using a sum formula. If the first row has 10, so that's A1, and then each successive row has 4 additional seats, so that's going to be D equals 4. So they want to know how many rows there are. All right, so if I start off by just writing the normal rule, I can say, hey, I know this is going to be 10 plus n minus 1 times 4. I'm just going to clean this up by distributing this through, so I'll get 4n minus 4, and I got that 10 chilling right there. So that's going to give me 4n plus 6. And the reason I did that is because the sum formula is going to involve that little formula we just found, because n is what we don't know. And so right now, if I were to direct substitute stuff in, I know that that's going to be 240. I know that A1 is going to be 10, and I don't know what n or an is. So too many unknowns in one equation, and so we'll use substitution to say, all right, that's 10, and here is what an equals, so 4n plus 6. All right, I'm going to multiply the 2 to the other side, so I'm going to do whatever that is. Totally didn't need a calculator for that, and I don't know what you're talking about. This is going to become 4n squared when I distribute the n through, plus 16n. I believe everything is divisible by 4 here, so if we want to clean this up, we totally can, and we will get something along the lines of this, and then we're just going to quad form this and figure out what n is, remembering that n has to be a whole number and that it has to be positive. So I will leave that to you to be able to figure out on your own. Geometric sequences. So here is our next main formula that we need to have memorized in order to be successful with geometric sequences. So it's A1 times R, the common ratio. So that's what you're multiplying by each time. And then raised to the n minus 1. And we have the sum formula down here. And there's 2 different variations of this one. So one is for just any old sum, and one is for something called an infinite sum. And the infinite sum only works if your R value is between -1 and 1. So again, you just got to memorize those and be familiar with them. So same exact idea as before. We're going to write a rule for the geometric one. So geometric sequence, we're going to make that system of equations again. So I'm using the general rule saying I don't know what A1 is, I don't know what R is, but I know that n is going to equal 3 for this particular term. Same thing with the 405, don't know what A1 is, don't know what R is, but I know that n is going to be 5 for this. So what I want to do is rewrite each one of these as A1, because this is a system, but I can't just subtract because I have this multiplication here. and that's not going to work out too nicely. So I'm going to do 45 divided by r squared, and this one I'm going to do a1 equals 405 divided by r to the fourth. And now I can set these two things equal to each other. So 45 over r squared equals 405 over r to the fourth, and cross multiply, which I will write way up here. 45 r to the fourth equals 405 r squared. I'm going to subtract this to the other side, set it equal to 0. I'm going to factor things out. My assumption is that this is going to factor out nicely with the 45, but I don't know. That's why I got the calculator ready to go. I got minus 9. So I'm going to get r equals 0, and then r equals 3, or r equals negative 3 from this. R cannot equal 0. It can equal either one of these. So when I go to write my rule, I have to include both. Now, this is not likely to show up on a final, I feel like, but it is a possibility. And I think you've maybe realized what I realized, which is that I don't know a1 yet. So I got to take one of these ones and plug it in. I'm going to do it to this one. So a1 equals 45 over 3 squared. It's not going to matter if I do positive or negative 3 there, because when you square it, it's going to give us 9 either way. We're going to get 5. So both of these work for this particular set of terms that they gave us. All right. So now we have a series, geometric series. So we're going to do, this is the first 6 terms. So I'm doing S6, which is going to be the first term, 1 minus the r value, which is 3/2, raised to the 6th power, over 1 minus the r value. And then you just very carefully type that into your calculator. My suggestion is that you put parentheses here, then divide and put parentheses here. Since we do tend to mess that up, I'm going to do that answer key. I also just added parentheses here, just so you know. I got 83.125, which you could write as a fraction if you really wanted to. This one is an infinite sum, so we're doing S infinite. So we're going to do a1 over 1 minus negative 3/4, which we're totally allowed to do infinite because this r value right here is between -1 and 1. And then we just very carefully plug this into the calculator. Again, I added parentheses here, like that. And I got a really weird decimal. As a fraction, it is 8/7, which is much nicer than the weird decimal I got. All right, next I think we got just some word problem stuff for you to be familiar that uses geometric. So this is a working backwards one. We have what is a1 when we have 10 terms, common ratio is 0.5, and the sum is going to be that. So we're going to just plug this in all to the formula. So 1 minus 0.5 to the 10 over 1 minus 0.5. And we're just going to figure out what this decimal is right here. So whatever 1 minus 0.5 raised to the 10th divided by 1 minus 0.5. It's some super weird decimal at 1.998, blah, blah, blah. And I'm just going to divide that to the other side. And I got a1 equals 256. And that's my answer. All right, our pendulum. So our rule for this guy is going to be 20 is the first swing, and then we're doing 0.8 every other swing after that. So if we want to figure out what the length of the arc is on the 10th swing, we're just going to do a 10 and do 20 times 0.8 to the 10 minus 1. I'll leave that for you to do on your own. This one is saying on which swing, so we're still singular swing, so we're using the same formula. This time we want to know when is it going to be less than 12, so I'm just going to set it equal to 12. That sounds easier to me. And now I need to solve for n, on which swing, so on the nth swing. Which one is this going to be? I'm going to divide by the 20 here, so that's going to give me 0.6 equals 0.8 to the n minus 1, and I'm going to switch to log form. And we'll do more on log form in another one of these little lessons here, but I'm just going to, my calculator doesn't have log base, so I have to do the change of base. So it's going to be log of 0.6 divided by log of 0.8. I got a really weird number. I'm going to add 1 to that. I got that n is going to be 3.289. That means that on the 4th swing, so I'm rounding up, this thing is finally going to become less than 12, because on 3 it's still bigger than 12. So it's when it's into the 4th one during this 0.289. After 15 swings, plural now, we're using the sum. So this is asking us for S15. So we would just use our first term, 1 minus our ratio raised to the 15 over 1 minus the ratio. Again, I'm going to leave that for you to figure out. This one's asking us the total distance still plural for all of the swings here. And since they didn't give us a specific number of swings, we know it's going to infinity. So I'm going to do the a1 divided by 1 minus 0.8. Again, I'm just using these three formulas that are way up here now, just to make sure that I'm good to go. Last one is this very specific type where we have the bouncy ball. There was like 800 different ways of setting it up. So my preference would be to do 8 plus 2 times the infinite sum of all of the rest of the bounces. So that's all of these ones. So in order for us to do that, we need to figure out what is the second height. So I just did 8 times 0.75 and I got 6. It was in the picture, but I wanted to make sure I was doing it right. And then I do 1 minus 0.75. And that's going to be what the total distance of the ball is. So just to kind of reiterate, this is the first bounce. This is because up and down are going to double the distance of every other one that I put in the box here. And then this is going to give us the sum of all of those ones. So that's just a very specific type that happens occasionally. And there you have it. That is sequences and series in a crash course. Hope you found that helpful.